All right, welcome. In this video, I want to do an example of Straasen's algorithm. And so to get started on that, we need a little example. And the simplest way to practice and work with Straasen's is to work with the smallest kind of matrix that we can, which would be a 2 by 2 matrix. So here I've got two 2 by 2 matrices. I've just sort of made them simply here with 1, 2, 3, 4, 4, 2, 3, 1 as my inputs, just to give us something simple to compute. And then I actually haven't computed the final one here, so let's actually go ahead and do that. Let's start with the first one. Maybe I'll do a little scratch notes down here. So we're going to do first row times the first column. We're going to get 4 plus 6, it looks like here, is 10 for my first one. Now first row, second column, we're going to get, looks like 2 plus 2 for 4. Now our next row and next column, we're going to get 3, 4, 3, 4. So what's that? 3 times 4 is 12. And again is 12 is 24. And then let's do our last one, 3, 4, 2, 1. What's that going to be? It looks like 6 plus 4 again equals 10. So what we've done here so far is we've just done normal matrix multiplication. And remember that in our analysis that what we've done is effectively n cubed operations here. In this case, we've got n equals 2, which is small, so that makes it easy for us to do this. And again, what would that be? 2 cubed would be 8. Well, we're kind of, if you kind of look here, 1, 2, 3, 4, 5, 6, 7, 8. Each one of those numbers I've flagged there represents one multiplication that we did. So this here, when it says n cubed time or n cubed multiplications, we've gone ahead and seen that. We verified that we did that many multiplications to compute our result. Now, we're going to try and practice Straasen's algorithm now, which we know can shave off a little bit off of this exponent here. Okay, instead of n cubed, we're going to get n to the log base 2 of 7. And since 7 is less than 8, and 8 would give us a 3 here if we had log base 2 of 8, we can see that this would be a little bit better. Now, the purpose of this video is not really to save us time. In fact, it's probably going to take us more time by hand to compute it by Straasen's way than it just took us to do it by the straightforward way. But that's partly because we're still with n equals 2. And remember that this is an asymptotic comparison, meaning we really only want to use Straasen's algorithm when n is really, really big. When n is small like this, n is 2, we should probably just do what we just did. Now, the reason I did what we just did is so that we have something to check our answer against. Afterwards, when we're done doing Straasen's algorithm, we hopefully we'll get this same resulting matrix. If we didn't, we probably messed up somewhere. It's unlikely that Straasen's algorithm's wrong. We've tested it, we know it's right. So if we get the wrong answer, all we know is we've probably messed up our arithmetic somewhere. So let's go ahead and try now to think about how Straasen's algorithm works. Now, Straasen's algorithm works with a number of different sub-matrices that we're going to compute. I'm just going to start by writing out what the formula for M1 is. And I'm just copying this right from my notes. I haven't memorized this or anything, and that's partly because I don't find Straasen's algorithm very intuitive. I understand how it works, and I respect that it works, but I haven't actually captured the mathematical structure in my own mind so that I can, just develop on my own. So again, I'm just copying this out of my notes. Now let's just take a look here and see what this is saying. This is saying A11 plus A22 and B11 plus B22, and then multiply them together. Now, we're cutting our A and our B into submatrices. The way that Straasen's algorithm works is to divide our matrix into 2, and since our matrix is a two-dimensional structure, when you divide it in 2 on both axes, both on the horizontal and vertical axis, then you're going to end up getting 4 subcomponents. 4 quarters is what we end up getting. And so we see we've got 4 quarters here, and we're going to name them A11, A12, A21, and A22, just like we would in normal matrix labeling. And then we're going to take those and do whatever this formula tells us to do with it. So let's just kind of follow through with Straasen's algorithm here and see what it's saying here. So it says A11 is the 1 up there. So we're going to take 1, and we're going to add it to A22, that's the 4. It turns out in our B, it's the same. We get actually 4 plus 1, and that's going to get us, let's see here, 5 times 5 is 25. Okay, so somewhere, we know we're going to use this later on, M1. We did this calculation, we got 25. Just a quick look, there's no 25s up there. So we know that we're not immediately going to plug this in. And of course, that's not what Straasen's algorithm tells us we're going to do. We're going to need to combine a number of these together to get our C11 and our C12 and so on. And I'm going to get to that in a second. Before we get there, we need to go through the process of doing, all the m's. Each m is going to be computed with one multiplication, like we see here, and possibly some other number of additions and subtractions. And so out of the, if each one of these m terms that we have is going to represent one multiplication, and we have 7 multiplications, that's where this 7 is going to come in up here. Okay, so we have to compute these 7 intermediate products. Let's go ahead and do that. All right, the next one here, A21, that looks like it's our 3, plus A22, that's our 4, multiplied by, and let's be careful here, B11, which is also a 4. So 3 plus 4 is 7. 7 times 4 is 28. Okay, again, not up there, but remember, we're combining these together to get those terms up there. So let's get our M3 set up now. Okay, so M3 looks like what we've got here is A11. What's that? That's going to be our 1. Multiplied by B12. 12 is our 2. Minus B22, which is our 1. So this one looks like 2 minus 1 is 1. 1 times 1 is 1. Okay, keep going. M4. So this one is A22, which looks like it's our 4. Multiplied by B21. 21 is 3. Minus B11, which was 4. So 3 minus 4 is minus 1. 4 times minus 1 is minus 4. All right, let's keep going here with M5 then. So we get A11, which is 1, plus A12, which is 2, times B22, which is 1. So it looks like we got 1 plus 2 is 3 times 1 is 3. All right, another one. We got A21. A21 is 3, minus A11, which is 1, multiplied by B11, which is 4, plus B12, which is 2. So what do we have here? We have 3 minus 1, which is 2. We have 4 plus 2, which is 6. 2 times 6 is 12. So we're on to our last product now, which is M7. So our last product, we got A12, which is 2, minus A22, which is 4, multiplied by B21, which is 3, plus B22, which is 1. This gives us 2 minus 4, which is a minus 2, multiplied by 4 gives us a minus 8. So now we can combine these intermediate products together to calculate our actual value. So the first one I want to look up here is C11, and it says if we take M1 plus M4, and then we minus off M5, and then we add on M7, we should get C11. All right, let's calculate that. So M1 is, it looks like 25. And then it says add on M4. M4 is minus 4, so adding it on means minusing 4. Minusing off M5. M5 is 3, so we'll minus off 3. And then we'll add on M7. M7 is minus 8, so adding it on means minusing off 8. Putting that all together, looks like 8, 3, 4, that's minus 15 here. 25 minus 15 is 10. Now let's go back and double check. Sure enough, C11 is 10. Looks like so far so good. Straasen's algorithm is getting us where we're aiming at. Now let's try the next one, C12. So C12 is easier to calculate. It's M3, which is 1, plus M5, which was M5. It was 3. That gives us 4. Sure enough, C12 is 4. Okay, still so far so good. Remember, Straasen's algorithm is correct, so we should trust it. But we may have messed up some of our arithmetic along the way, so we're really just double checking our math. So let's keep going. C21 is going to be an M2 plus an M4. And our M2 was 28. And our M4 is minus 4. So adding it on, we get 28 minus 4 is 24. Let's go back up and check. Sure enough, 24. Okay, our last one we're looking for here is another 10. So our last one, our C22, is going to be an M1 plus an M3 minus an M2 and plus an M6. So let's see what that gives us. So M1, let's go back up here. M1 was 25, and our M3 is a 1, so we add on a 1 here. And then our M2, what was our M2 again? Oh, it was 28. So, now we minus off 28. And then we plus on M6. And where is our M6 here? Our M6 looks like it's a 12. All right, so let's do the math here. We're going to get 25, well, plus 1, that gives us 26. That's going to be kind of easy. And then plus 12, that will give us 38 in my scratch, minus the 28 is 10, and that's what we were looking for. So sure enough, the matrix that Straasen's algorithm tells us, the resulting matrix will be 10, 4, 24, 10, and again, checking that against our previous answer that we already calculated, we can see that that is indeed correct. So what we've just done here is, this isn't really a proof of correctness of Straasen's algorithm. All this did was allow us to verify empirically by doing one example of some numbers that indeed the equations that Straasen came up with for his algorithm are indeed correct, at least for this instance. Of course, we might want to have a more formal proof or go review Straasen's formal proof that this is indeed true for all instances. Or if you just want to test your skills again, just put some different numbers here into A and B. And we'll and calculate it out and do a little bit of practice. Again, maybe by hand use the method you learned in matrix algebra to calculate the solution matrix before doing Straasen's algorithm so that you can double check your math. Okay, well, thanks a lot for watching, and we'll see you in that next video.